And we're back. Apparatus. A. Atomic absorption spectrometer, consisting of a light source emitting the line spectrum of an element, hollow cathode lamp, or electrodeless discharge lamp. A device for vaporizing the sample, usually a flame. A means of isolating and absorbing the line, micrometer or filter, and adjustable slit. And a photoelectric detector with its associated electronic amplifying and measuring equipment. B. A burner. The most common type of burner is a premix, which introduces the spray into the condensing chamber for removal of large droplets. The burner may be fitted with a conventional head containing a single slot, a 3-slot boiling head, which may be preferred for direct aspiration with an air acetylene flame, or a special head for use with nitrous oxide and acetylene. C. Readout. Most instruments are equipped with either a digital or null meter readout mechanism. Most modern instruments are equipped with microprocessors or standalone control computer cable. Standalone control computers capable of integrating absorption signals over time and linearizing the calibration curve at high concentrations. D. Lamps. Use either hollow cathode lamp or an electrodeless discharge lamp, EDL. Use one lamp for each element being measured. Multi-element hollow cathode lamps generally provide lower sensitivity than single-element lamps. EDLs take a longer time to warm up and stabilize. E. Pressure reducing valves. Maintain supplies of fuel and oxidant at pressures somewhat higher than the controlled operating pressure of the instrument by using suitable reducing valves. Use a separate reducing valve for each gas. F. Vent. Place a vent about 15 to 30 centimeters above the burner to remove fumes and vapor from the flame. This precaution protects laboratory personnel from toxic vapors, protects the instrument from corrosive vapors, and prevents flame stability from being affected by room drafts. A damper or variable speed blower is desirable for modulating airflow and preventing flame disturbance. Select blower zone to provide the airflow recommended by the instrument manufacturer. In laboratory locations with heavy particulate air pollution, use clean laboratory facilities. See section 3010C. 7. Quality assurance, quality control. Some data typical of the precision and bias obtainable with the methods discussed are presented in tables 3.1.1, semicolon 2 and 3. Analyze a blank between samples or standard readings to verify baseline stability. Re-zero when necessary. Re-zero when necessary. To one sample out of every 10, or one sample from each group of samples, if less than 10 are being analyzed, add a known amount of the metal of interest to and reanalyze to confirm recovery. The amount of metal added should be approximately equal to the amount found. If little metal is present, add an amount close to the middle of the linear range of the test. Recovery of added metal should be between 18 and 115%. Analyze an additional standard solution after every 10 samples, or with every batch of samples, whichever is less, to confirm that the test is in control. Recommended concentrations of standards to be run, limits of acceptability, and reported single operator precision data are listed in table 3.1.1, semicolon 3. The QC practices considered to be an integral part of each method can be found in section 20. 8. References. American Society for Testing of Materials, 1986 Annual Book of ASTM Standards. 2. U.S. Department of Health, Education and Welfare, 1970. Water Metals, number 6, study number 37, Public Health Service publication. 3. U.S. Department of Health, Education and Welfare. 4. U.S. Environmental Protection Agency. 9. Bibliography. Can HL 1968, Ramirez Munoz J 1968, Slavian W 1968, Paus PE 1971, Edgar RD 1973, Paus PE 1973, and Buriel DC 1975. Thank you very much. And this is the text that we're reading from. It's from the standard methods for the examination of water and wastewater. All right, thank you very much.